All right, so very good. We're working on this word problem, and bless you. What we said was that we wanted to, in setting this up, this is number 12 on page 124 for those of you that are watching at home, and we wanted to set our unknown to be the shorter length. So we got these two rectangles that are going to have the same area, and so I would suggest let your unknown be the shorter length, and then as we mentioned just a moment ago, we could let x plus 3 be the longer length. Now, Cullen told us that the area of a rectangle is length times width. So what would my equation look like, Thomas? If I know their areas are supposed to be equal, what do you think? What would the area of the red rectangle be? Good. And the area of the blue rectangle is 8x, and they're supposed to be equal. Good. So that's our equation. Now the picture helped us write that equation, right? And then from here, it's just a simple matter of solving it out. I would assume everybody in here is comfortable with that's step 4 in the word problem solving method, where we just multiply both sides, we distribute both terms by 6. We get 6x plus 18. Subtract 6x from both sides, and we get x equals 9. Now that doesn't answer the question, right? John, what would the answer of the question be? What are they asking, in other words? So Jen's length, the length of her garden, would be 9, and then Leo's would be what? 12. What would their areas be, by the way? What do you think, Grady? 72. Yeah, very good. Because 6 times 12 would be 72, and 8 times 9 is both 72. So, that's a basic word problem. I think that's a B-level question. That was number 12 that we were looking at. But it's an example of, did I really need a chart for that one? No, I didn't need a chart. Okay. Now, if I had done it using a chart, here's what that would have looked like. We said yesterday, Leo, length times width equals area. We said yesterday that you organize the charts by sort of putting the border together. Well, there you go. The length of Jen's was x. The length of Leo's was x plus 3. We knew all of their widths. Jen's width was 8 and Leo's was 6. So you multiply from left to right, 8x. And then you multiply from left to right, 6x plus 18. And then what we were saying is that you would equate those two areas. The two areas are the same, so that's where we would have come up with that equation. You could have used a chart there, but like I said, if it's a problem where you can actually draw a picture and visualize it a little bit better, I think that makes more sense for us. Okay? So this is in the section talking about charts, and you could certainly use that chart. But I like the pictures a little bit better. All right, let's look at another example. Oh, let's see here. This is number 18 on page 124. All right, so number 18. And again, practicing making either drawings or charts, sketches or charts for each of these. It says 9 cartons of juice cost the same as 5 fruit cups. Also, 1 fruit cup costs 50 cents more than 1 bowl of soup. So we got soup, fruit cup, and juice. Why don't I declare my variables? Why don't I say, let J equal the cost of a juice cup, right? What else? Maybe F equal the cost of a fruit cup. And what's the third and final thing? Soup. S equal the cost of the soup. Now, it says that we've got these ways of comparing things, right? It says 9 cartons of juice, so 9 juices, 9J, costs the same as 5 fruit cups, so 5F. It says 1 fruit cup costs 50 cents more than 1 bowl of soup, so S plus 50. Good. Plus 50. And then what's that last one? It says 1 bowl of soup costs 50 cents more than 1 carton of juice. So J plus 50. All right. What would be the cost of each item? A carton of juice, a fruit cup, and a bowl of soup. Okay. Now, we said in class that early on in algebra, you don't really get used to, or you don't really get comfortable using 3 variables and 3 equations. But fellas, this is what it looks like. If there are 3 unknowns, which there are in this case, you're trying to come up with 3 equations. Okay. And then we mentioned that it's helpful if you want to look at it just using the 1 variable, and you want to try and write 1 equation in terms of that 1 variable, that maybe you could consider which variable they talk about the most. Is there a variable that they talk about the most? Well, let's see. How many times is J mentioned? J is mentioned once there and once there, so J is mentioned twice. How many times is F mentioned? Twice. And how many times is S mentioned? Twice. So, that rule of thumb really doesn't help much. If all 3 of the unknowns are mentioned an equal amount of times, then really it's just up to you. Okay, so you know what we're going to do? We're going to let Chase pick. Chase, if we want to work this just using 1 variable instead of 3, which one would you like to let stand for our variable? I'm going to give you carte blanche. You'll let F be our unknown. All right, so here's what we're going to do. Instead of using all 3 variables and writing 3 equations, which is how I kind of like to do it, I think the majority of you guys said, we're not quite ready for that just yet. Let's try and just use F, okay? So, for example, F is the same thing as S plus 50. So could you tell me what S is in terms of F? Could you get S by itself here in that second equation? What would you have to do to both sides? Very good, Grady. We would subtract 50. All right, so S is the same thing as F minus 50. So I'm going to go up here, and instead of S, I'm going to write that. I'm going to say F minus 50. Okay? How could I do the same for J? What do you think? How could I replace, again, you got any ideas? Which of my 3 equations down here would help me relate my 1 variable that Chase has chosen, F, and J? Which of our equations has F and J in it? All right, and so if I wanted to get J by itself, what would I do to both sides in that equation? What undoes a times by 9? Divide by 9. Very good. Divide by 9, divide by 9. And so we wind up with J is the same thing as 5/9 F. So I could come up here, I could say, well, instead of using J, I could just write 5/9 F. Now I've got all 3 in terms of what? In terms of the same variable. Mr. Webster.
Could you also just find S and subtract 50? Subtract 50 cents to get J?
Well, and you know what? That's the idea. If you didn't hear that question, it said, could you just find S and then subtract 50 cents from that to get J? And you absolutely could. What you're doing is you're referencing that third equation there. So, for example, J could be the same thing as S minus 50 if you wanted to. My point is this. If you've been given information like we've been given, we've been given a bunch of information, be able to manipulate that information. Be able to say, hey, I can, if I know that 9J is the same, 9 juices is the same as 5 fruit cups, then I ought to be able to manipulate, like Gannon said, hey, divide both sides by 9 and you get 1 juice is the same thing as 5/9 of a fruit cup, okay? Or, as we did earlier in the middle problem, saying, hey, 1 bowl of soup is the same thing as 50 cents off a fruit cup, okay? Now, what have we not done? We've gotten all 3 of our unknowns expressed in terms of the same variable. What have we not done, though? Jacob? We have not put it into one expression, Okay, so that's where I would look to maybe that third one that we hadn't dealt with just yet. Instead of S, what could I write? What do you think, Will?
F minus 0.5.
Very good. So I could say F minus 0.5 or 0.50, whatever. And then instead of J, do the exact same thing. Well, what could I write instead of J? What do you think, Grady? 5/9 F. And then don't forget the plus 50 at the end. And now look at what we've got. Just like Will said a moment ago, I think, we've got one equation in terms of one variable. Now, is that an intimidating looking equation? Yeah, kind of. What makes it a little bit, I don't know, a little bit unsettling, Nick? What do you not like about that equation? Yeah, it's got a fraction in it. It's also got some decimals in it. However, don't be scared. We can deal with this equation that I've underlined here in red just the same as we were dealing with that equation up there that's highlighted in yellow. What did we do? We tried to combine like terms. We tried to distribute, simplify both sides first. Then we tried to move some terms around, adding, subtracting, and then at the end we divided. So we could do the same thing here with this equation in red. Okay? So for example, I might want to say, let's add 0.5 to both sides. What's 0.5 plus 0.5?
1.
Well, there goes my decimal. That's nice. And if I've got 5/9 F on the right and 9/9 F on the left, did you notice what I just did there? 9/9 is the same thing as 1. Okay. Why don't I subtract 5/9 from F from both sides? 5/9 F minus 5/9 F. And we got 1 on the right. And how many ninths on the left? 4/9. All right, so we're taking our time. We're solving this out. Stephen, what's my last step? What do I do to get F by itself?
Divide by 4/9.
Very good. And if you heard him, he said divide by 4/9. And Marky Mark and the Funky Bunch, what is dividing by 4/9 the same thing as doing? Very good. Multiplying by that R word, class? Reciprocal. So multiplying by 9/4 here gets F by itself. Y'all have no idea who Marky Mark and the Funky Bunch is, do you? Y'all ever heard of the actor Mark Wahlberg? All right, so he used to have a band or a group called Marky Mark and the Funky Bunch. And it was probably back in the 80s, maybe early 90s. It was a long time ago. But anyway. All right, so we got F equals 9/4. Well, now what in the world does 9/4 look like in this context? We're talking about dollars and cents. How much dollars and cents is 9/4? Because if I said, hey, Cullen, can I borrow 9/4 of a dollar? Right? He's going to look at me like, are you crazy? But how much money is that? $2.25. Very good. So make sure when you guys are working these problems out, 9/4 is the math answer, okay? But it's not the contextual answer. It's not a good answer in the context of the problem. Saying instead, hey, this is going to be, a fruit cup is $2.25. Now I don't know what kind of daggum fruit cup costs $2.25, and this book was written in the early 90s too, so I mean that would be really expensive. Maybe they're at Disney World or something. But if the fruit cup costs $2.25, how much does the soup cost? Look up there at the top. $1.75. $1.75 because it's 50 cents less. And then 5/9 of that, well, I would have to think about the juice being 5/9 of whatever F is. So I'd come down here, and that actually in fraction form would be a little bit better. Juice would equal 5/9 of 9/4. The ninths cancel out, 5/4, which is 1 1/4, right? And now we've got our answer as far as the pricing goes. Now that's not an easy question. There's a lot of information coming at you. We had an opportunity to maybe write 3 equations and use 3 variables, or as we did, write all 3 unknowns in terms of 1 variable. Okay, now I had some questions. I feel like Campbell and JT. Go ahead, JT. How we got J, like the answer as far as juice cup goes, or back where we were coming up with J? Okay. So the question was, how did we get juice? we had said that f is 9/4 or f is 225, right? And earlier in the problem, we had said, hey, look, the juice is going to be 5/9 of f, 5/9 of a fruit cup, okay? So whatever that fruit cup is, we want 5/9 of it. So the juice is going to equal 5/9 of means multiply, whatever that fruit cup costs. And so 5/9 times 9/4. And when we multiply, that's why I was saying the 9s would cancel out, and you'd be left with 5/4, which is also the same thing as 1 1/4. And then Campbell?
Also, I have 2 questions. First question, on the last question review, it said 1 bowl of soup costs 50 cents more than 1 kind of juice. Couldn't you just take soup then and subtract it by 50 cents?
That's actually what Aiden did. If you didn't hear what his question was, he said, if we know that we know the fruit costs $2.25, and it says the soup costs 50 cents less than that, that's exactly what we do. We would say, hey, $2.25 minus 50 is going to give me the $1.75. Now, you might also be saying, I think I'm smelling what you're stepping in now. I think what you might be saying is that, hey, once we know that the soup is $1.75, didn't they say that the juice was 50 cents less than that? I got you. So you could just take 50 cents away and get your $1.25 that way too. More than one way to work that problem for sure. Okay? All right, so very good comments so far. I'm going to call it quits on that screencast. Just a couple of examples. Working word problems on page 124.